here, and all the stuff we were just talking about, I said it's built on redfish and swordfish. So what we really want to switch gears here a little bit more and say, so what's actually going on with swordfish? And there's a lot there. And what's the work that's happening on managing the storage fabrics? So there's a lot of work that we've been doing over the last year and a half, in particular about ensuring that we have comprehensive modeling for NVMe OF and representing NVMe and NVMe OF devices. So we'll talk a little bit about that now. All right. So what is swordfish? As we talked, I've mentioned redfish and swordfish repeatedly here, but DMTF redfish is a REST-based management standard that covers server, data center, and basic fabrics management. So that REST API is supported with JSON payloads, and if you're, depending on your favorite flavor, if you want to actually do schema-based development, we have 3 different flavors so folks can interact via and see our schema and interact, build applications in CSDL, JSON, or YAML. Swordfish basically leverages all of that and then extends it to cover the storage-specific use cases. So I'll talk a little bit more in a minute about what specifically that includes, but that we have, storage management that covers block, file, and object. And then with this architecture, we're able to extend our, storage domain coverage to include those converged environments. That's that partnership of redfish and swordfish, because they're the same, the same standard extended. You really get that very cohesive view from both the implementation side as well as the client side. Swordfish also has an option for implementation for more advanced systems to utilize a class of service-based provisioning, managing, and monitoring representation in the system as well. So what are we working on? We have a release that's coming out, was just approved for release earlier today. And so it'll be hitting the website very shortly, called Swordfish version 1.2.4, that adds a bunch of expanded support for NVMe and NVMe over Fabrics devices. And this again is done through an alliance partnership. We have NVM Express, DMTF, and SNIA Swordfish folks participating together in a joint effort to develop the common representation for how to manage NVMe and NVMe over Fabrics devices in a common way. So the storage fabrics, as we get the basics of that in place, then we're also doing this work that we've already been talking about with OFA to expand that to make sure it covers a broad range of fabric types consistently, where SNIA and Swordfish will focus on exposing the functionality for the storage-specific portions. So we have a lot of new documentation that's come out. We just released, well, as of today, we'll hit the website here in a couple of days. New white paper that talks about how clients and implementations can and should expect to see metrics and reported through the telemetry service in Swordfish. We've also got a lot of work going on expanding the user's guide, mapping guide, error handling guide. That mapping guide is really key. It's the mapping for NVMe and NVMe OF to Swordfish. So if you're literate on one side and not the other, this document will tell you exactly how to translate between those two specifications. We have additional work coming up later this year around supporting the NVMe version 2.0 of their spec, as well as looking at expanding some support to things like computational storage. And this covers some of the stuff I just said. The 1.2.4 releasing April 22. You guys get the latest, greatest update that this was approved for release today. And it's still April. So the NVMe specific content I've talked through, there's a lot of NVMe specific content in here. So when we're talking about how to manage that, we have we've added a bunch of schema for new properties, no objects. We map them back to the original objects, which I'll show in a minute. And then we've added a bunch of specific NVMe use cases as well. So if someone's coming in and says, hey, I'm thinking in NVMe world, how do I, attach a controller to a namespace? Our user's guide actually shows use cases for that and using NVMe language so that folks can easily find and reference that. One of the other sites we have, and I showed this in the demo yesterday, is swordfishmockups.com. So we use mockups quite extensively as a development tool. And we encourage it for folks doing product development as well as spec development. They're a great development tool. The other piece we have are a whole bunch of profiles. And what profiles are, and we've just released a whole new set of these, profiles are a way to specify a common set of required properties and objects that need to be implemented for a particular feature or function. So for an NVMe drive, there's a profile that says these are the objects you need to support and the properties you need to support. So clients can expect that consistently. Let's see. So if we talk a little bit about what are the basics of NVMe, and these are kind of some of the high level constructs in the NVMe space. So there's a notion of a thing called an NVMe subsystem. And it's basically all the representation, at the top of the hierarchy here. Instrumentations can have multiple subsystems, but they look like discrete logical entities when you interact with them. The next thing we have are controllers. These are all logical controllers with 3 different kinds. The IO controller is how you map access between hosts and namespaces. And namespaces are, just block capacity allocated, so they're volumes. A couple of the other objects that exist in the NVMe space are things like endurance groups and sets. So, these are a way to carve up based on attributes all of the underlying capacity and represent them according to those defined properties. So endurance group is really talking about that related capability of those of the capacity inside that. And then within an endurance group, you can also carve them up into multiple sets. All of those are things we've been able to map to existing models. And we have a few places where we've actually needed to create some new models in the swordfish side, which comes back to things like the NVMe domains. Everything else we've largely mapped to the existing models. So talking through all of those various things, you can see we have this is on the left over here is really the existing model for managing any type of block storage today. So there's a storage at the top is the object name, but that's really a representation of anybody's system. And within that, you have things like controllers. In traditional storage, that's more a hardware physical controller representation. In NVMe, it's a logical controller representation, but it fits well into the hierarchy to map these IO controller, admin, discovery controllers into this same controller notion. Then when you have a storage system, you allocate your capacity into storage pools. And that again maps what I was just talking about with endurance groups and sets. So in Swordfish, we've had the notion that you can have pools of pools. You could have a pool made of volumes. You can have a pool of pools. You can have a pool of drives. Whatever those things actually look like, you can see at the high level, this model actually stays the same. And this is really, really helpful for us when we're looking at providing continuity from existing storage types to new storage types, or even both in the same system, which we will see as well. And representing all of those in a common model. So this is kind of, again, what this looks like. If you're looking at an NVMe drive in Redfish and Swordfish, it's higher. It uses this rest-based hierarchy. We have what we call the service root up here, and then we have the logical representation that all comes under the storage hierarchy. And then physical representations are done over in chassis. And there's other things like registries and a bunch of services and things in here that I won't get into too much today, but that are basically help just build a complete management ecosystem. So in the storage subsystem, you can kind of see this underlying set here looks like traditional storage. You have storage pools that you create volumes out of. This up here is just a way to find all the volumes in your subsystem at once. Then you have controllers, and then you have some physical representation, which would come down here under chassis. So this instance here, or this representation we're showing here, that would show some of these links. These dotted lines are links as opposed to containment. You can see links back and forth all over the place from point to point to help navigate around the system. And then you can also see the mapping of those objects as NVMe objects I just talked about into this redfish and swordfish model. There's a little key down here that describes all of those as well. Okay, so that's the basis of the model, but then we start to getting into NVMe over fabrics. So where's the fabrics part? I haven't shown you that yet. So here's where we get to is this over here, the red is a portion of the fabric model. There's really two different things that are shown in the fabrics model. The first one is access rights management. Second one is connectivity. Well, the first thing we tackled here, because that's what's in, that's what we're looking at in terms of functionality coming from NVMe and standardization around NVMe OF, is access rights. So this picture actually is just reflecting how access rights would be managed, because overlaying connectivity on the same picture just gets a little bit ugly. But what we do is we take things like where NVMe OF, so this example on the right is showing an exported subsystem, and these can all be these are all logical constructs here. So you have subsystem, we've already talked about namespaces. Well, that's clearly a volume. And then there's some other things down here that are all around configuring access rights and connectivity. So the allowed host is entirely about about access right management. And so that you see reflected as that links over to the connections. Endpoints are an abstraction of the connection points here. So we don't have, you're not connecting physical to physical, you're connecting to a logical construct, and the endpoints serve multiple functions here. So these are just kind of some of the basics here that are reflected. And when you get to a full implementation that includes the underlying fabric connectivity, in addition to just this basic NVMe OF model, you'll see switches, you'll see other things actually showing up over here, because you see there's not anything that really corresponds to a switch here. The switch would be in the F part, right? So if this is NVMe over Ethernet, there'd be an Ethernet switch. Over fiber channel, you get a fiber channel switch, and then those model in and help reflect that connectivity. That's that next piece. So this gets a little bit complicated with putting all these layers together, because we're basically taking those NVMe devices we saw in the first place and then layering on a level of abstraction on top of that to create logical subsets of that or groupings, either way, and reflecting that. So let me just walk through this a little bit. What you have over here is you have in chassis, you have an underlying drive. So we can walk around and say, where are all the representations for that? So as we saw in that first case, here's the representation in storage, this instance. This corresponds to that to an underlying NVMe drive that's in the system. And here's the controllers for accessing that. Here's the storage pools, endurance groups, and sets, and then the volumes that were created from that underlying drive. So one drive has one namespace here in this model. Okay, so now we say, well, we want to take that and we've got it mapped to a system, but we want to export it and make it accessible someplace else. That's where the rest of this model comes in. So then we get to this additional storage instance here that is looking at now has an NVMe. Oh, sorry, I didn't quite point out this drive here. The way this is reflected, you can actually see that it's actually connected as part of the system. So you could say, oh, that's most likely a PCIe drive. We'd have to go down into details to confirm. But I want to export that capacity over Ethernet to another system. That's what we're going to do in the rest of this, or over, whatever transport. So we've created this other storage instance, and that has what we just looked at there. So it has this logical namespace, and that logical namespace is created from this, you can follow this around, right? So this namespace is actually down in over here, but these are the providing volumes up to this logical namespace. And that's how you get, the creation of this logical namespace. And this is just a pointer to it. So I hope that wasn't too convoluted of an explanation, but you also see over here these links between the connection. So there's an endpoint for the host, an endpoint for the NVMe. It says NVMe endpoint, but it's basically referring to this these logical constructs over here. And there's a zone that groups them together, say, okay, this host and this endpoint are in the same zone. And then this connections down here would define any access rights that gets laid on top of that. So it's a relatively comprehensive solution and allows us to layer multiple different types of devices together using the same models. So again, we've been working with DMTF and OFA here to apply and extend the base Redfish fabric models to multiple fabric types. Redfish really just provides the high-level model and the basic technology. They look at organizations like SNIA and OFA to come in and CXL and Gen Z and everyone else to come in and say, do I have everything that I need for that model to be complete for my fabric type? And then as we get those put into place, we can start working on those storage specific capabilities. So storage fabric management. We've had SANs for a very long time. This, a lot of, basic SAN management falls into here. But then there's also looking at across these new different types of, workload optimization, performance instrumentation. Those are all the functions that really get down into the storage application. The application of optimization to the storage portion of the system. Let's see. So these are just some views that go back and talk a little bit about that they show that connectivity and the access rights that I talked about earlier. Right, we had the model here that showed access rights. And actually, let me flop over this one and we'll go back. The access rights, which we've already looked at, connections and endpoints working together with under fabric to provide that low access. The next thing you layer on comes into managing connectivity. And one of the things we've learned as we walked through this process of detailing everything out for different implementation types is it really is helpful to separate how you're reflecting your connectivity from your access rights, even though they're both under the fabrics hierarchy. Having them as distinct fabrics, one that's reflecting your connectivity and one that's managing your connectivity, really helps simplify presenting it from both a vendor side as well as finding information from a client side. So if you see two fabric instances, that doesn't necessarily mean there's two different physical fabrics. It may mean that you'll see one that's here's the NVMe OF connectivity, and here's another one that is my fabric connectivity underneath. So whatever the F is underneath that. We've got a couple of mock-ups done. Oh, yeah, sorry. So just one more little note here is that this is where the OFMF comes in. Underneath this is, plugging in and providing the instrumentation up into these fabric models for all the various device types and flushing that out. All of the rest of this model, it's basically, here are the upper level models, and the OFMF is working on the translation from this level down to the different fabric types. So we have a lot of mock-ups that actually show this. One of the things I'm just highlighting, I picked one of the simpler bubble diagrams here because the bubble diagrams can get a little overwhelming. But we have representations that show how to do this on and how to reflect connectivity on Ethernet attached drives. And then in an EBOF configuration, we have a much more complete mock-up that actually shows all that fabric management that I just talked about. So again, these two fabric instances, this NVMe OF one over here, this just talks about access rights. And then the Ethernet one over here is your classic Ethernet connectivity for the EBOF enclosure reflected in the Ethernet fabric. So this particular model and mock-up actually have the physical environment they're modeling is an EBOF enclosure that has a couple of ports a couple of built-in switches, and those switches are connected on one side to the internal devices, aka the Ethernet attached drives, and then they have external connectivity as well. So all of that is modeled here. So things like when you're coming down from the EBOF, you see these new little pieces here, the network adapter, port, network device function we haven't talked about. These are just classic, the network management models within Redfish that are included here to provide that comprehensive view. So you could trace yourself all the way down from, I'm connected, on the EBOF is connected from this NIC, but the endpoint, it's configured so that these endpoints are exposed and represented in this network device function. And then there's port connectivity and others you could trace your way around as well. These mockups are available on swordfishmockups.com. As part of the release we're pushing out today, we will have a whole series of new mockups out on that site, probably within a week or two. So that's kind of a bit of an overview. There's a lot of different different moving parts and a lot of places to find things. The key one from Swordfish is go to SNEA.org/swordfish. But I've also put contacts and information up here for how to find things from all of the partner organizations we're working with to make this a comprehensive solution. All right, so Phil.
So I did have one question. When it comes to access controls and access rights, what do you mean? What does that allow you to access? What granularity?
Okay, so that's a multi-layered question, and the information is reflected in different parts of the model depending on which access rights you're talking about. In connections, think of it as I'm connecting. I'm saying which endpoints can connect to other endpoints and what permissions do they have. So if it's block access, there's a construct that basically says, is this read write, and I map it to those connections. So at a very high level, what you're saying is, here's my host or group of hosts that I want to be able to access that endpoint, and that endpoint can reflect, basically an individual namespace or group of namespaces as well. And so it's basically, how do I want to connect at that level? How do I want to manage access rights at that level? Is it read? Is it read write? Is it none? If the none version is really that there's not a representation for it. If there's not a representation for it, it means that access has not been enabled. So that's the level that the access rights are coming in at. When you switch to, if you have very technology specific, other access rights are more granular. It's like ANA access. reservations, how to manage persistent reservations on a specific topic. That's actually done at a different layer in the system that's not included in the connectivity or in the access rights model.
Okay. And a question I didn't get over the chat, but one I get asked a lot is, Redfish Swordfish doesn't actually implement the functionality, right? What actually happens once the requests get to the system?
Yes, good question. Yeah, so this is Redfish and Swordfish are the API definition, and the service definition. So what is all the functionality that needs to be there? But at some level, you have to turn around and talk down to your device. So there's a few ways you can do that. One is a whole lot of people already have RESTful APIs. They can just marry these two things together on their management interfaces. The other thing that there's multiple different ways this could happen, right? People can embed that completely down into their system, if depending on the system type, but they could embed it completely in their management ecosystem, and then everything behind it is a proprietary interface. The other thing we can do is actually map it to other standards-based interfaces. So that's where some of the work we've been doing in the NVMe space comes in as well, is we have the mapping that says this is how these are the specific NVMe commands that these things map to. So you can take those through an NVMe admin command in band and map down so that the translation down to the actual device is through that, or through NVMe MI, if I'm representing and creating BMC Redfish and Swordfish instrumentation in a BMC, for example, that may turn around and say, I want to talk over NVMe MI. So it's a multi-layered system until you get down to the final source, and it's really up to the implementers, both on the vendor side as well as the systems, because a lot of the representation for Redfish and Swordfish are done at a system level. There's a third option in general, which is Redfish embedded all the way down into the device. And so that what it talks out is what we call Redfish device enablement. So depending on the device type, if you're talking about like a low-level device that's connected via, say, PCIe, and can talk at that level, it can actually export Redfish device enablement so that the intelligence and the Redfish knowledge are completely down in a device that's, even a small device that's attached via, PCIe to a system. So there's basically a nice range in there, and some of that is going to be vendors working with their customers, the OEMs and the like, to say, how do you want to access this? Do you want to build the Redfish layers? Do you want us to build the Redfish layers? And where everything sits in the system is dependent on those questions.
Cool. Thank you. Yeah, like I said, I get asked that question a lot, and I wanted to make sure that was touched on. Okay, thank you very much. I don't have any other questions queued up in the chat, so thank you for the presentation.
Thank you.
And